Features of the aircraft. This is a Piper Aztec twin, and it's a complex light aircraft in that it has retractable undercarriage, so it's a nose wheel type undercarriage, and you can just about see beneath the engine bulkhead the port main wheel, all of it retractable. Here we have the starboard engine. It is a Lycoming 0360, which will put out approximately 350 horsepower. You can see it's a 6-cylinder, horizontally opposed, air-cooled engine. Attached to the Lycoming 0360 is this variable pitch propeller. Simple aircraft have fixed pitch propellers. The Aztec had variable pitch, and that basically means you can change the thrust angle of the propeller blades depending on the phase of flight. So on takeoff you might have the pitch quite fine to increase the revs, increase the horsepower, but once you get up to altitude and start cruising, you'd want the blades to go more coarse so that you'll be able to get a similar amount of thrust without very high engine revs. That will save on engine wear and tear, but it'll also save on fuel while you're up there. To increase the range, the Piper Aztec has 3 separate wing tanks. And here's the wingtip tank, the smallest, which is used probably the first, so that the weight of the fuel ends up being concentrated nearer the centre of mass of the plane, which helps the handling. Next to the fuel tap, there is the navigation light. So this is the starboard navigation light, which will show red. So this is the aileron on the wing. This is the starboard aileron, and this controls the aircraft in roll. The ailerons work in opposition to each other, so to roll to the right, this aileron will be deflected upwards, while the aileron on the port wing or left-hand wing will be deflected downwards. Next to the aileron is the flap. These generally lower downwards for the landing approach, and this increases drag and increases the lift of the wing, which lowers the stalling speed so that this rather heavy aircraft can land in a relatively small space. When the Aztec is ready for takeoff, the flap will also be lowered, but not to this extent. This is the landing configuration. So approximately 10 degrees of deflection, much less, will be required for takeoff. And to control the aircraft in the pitching plane, we have a tailplane, or the Americans call it a stabilizer. Now, in this case, we have what's called an all-moving stabilizer, in that the whole of the tailplane pivots around a central point. This essentially increases the static margin of the tailplane, which gives greater stability overall. You'll also notice this rather large trim tab at the back, again to help trim the aircraft out over a wide centre of gravity range. Because it's a multi-seater aircraft, depending on who's sat where, the centre of gravity will shift rather more than, say, a 2-seat aircraft. And this large trim tab again, like the rudder, can be moved to ease the pilot's workload. You can see from this view that we have a fairly large tailplane or stabilizer that is quite a way back from the wing. So this is an indication that there is a fairly generous moment arm, which is the relative distance between the wing and the tail. And this further imparts stability on the aircraft, because generally up to a point, the longer the moment arm, the more powerful the tailplane or stabilizer's effect is in the phase of flight. Here's the fin and rudder of the aircraft. The fin and rudder work together to give directional control to the aircraft, but the rudder obviously moves relative to the fin to act rather like the rudder of a boat. It will yaw the aircraft left or right depending on which way you operate the rudder. You'll also see at the back a trim tab, quite a large trim tab, because with twins, if you have one engine out, there'll be quite a large yaw to one side, and this trim tab can be deflected to keep the aircraft straight when it's only flying on one engine. But also, in much smaller amounts, it can be used to keep the aircraft flying straight and ease pilot workload.